given mixture from a solution basically, right now. So there we did learn about sedimentation, we did learn about
Sir, also
filtration, yeah, and decantation also, right? Those three methods which we have learned in the previous classes, right? So
yes.
sedimentation, we did learn that whenever we have a mixture in which one of the component is heavier, basically it would be solid in nature. So when we have such a mixture and when we allow it to rest for some time, thereby due to the heavier component, due to the force of gravity, it will settle down at the bottom of the beaker, right? And the one that settles at the bottom of the beaker, that will be called as sediment, and the clear liquid that is left, that is called as supernatant, okay,
Yes.
no? So that is the thing about sedimentation. Then we did also learn about decantation. So decantation is done right after sedimentation. So once sedimentation has been done, you can see the clear layer of this liquid. Then now you can separate it in
Sir,
a
one
separate
word
container.
separating the supernatant with the sediment.
Exactly. So in the case of decantation, we did learn no, Hana, that decantation will be of two types. One where you would be separating the liquid component of the mixture from the solid component, that is sediment that has settled at the bottom. With the help of a glass rod, we'd be taking help of a glass rod because this will avoid the spilling of water outside the beaker. Okay, no? So decantation is done here. Also, decantation is done for that kind of mixture also, where you have got two immiscible liquids like oil, for example, kerosene oil, and water. Kerosene oil is less denser than water, thereby it will float above the water. So here also we can separate them using a separating funnel. So as we have turned on the stop cock, as it is open, so first of all the water will drain out of the separating funnel. Now, as soon as all the water would have drained out of this and we have collected this in a beaker, then we will close it. Then it is closed and thereby we have separated the oil and water. In this, only kerosene oil will be left. So that is also decantation. So decantation is separation of a solid from a liquid and separation of a liquid from another liquid also. Getting it, no?
Yes, sir.
So that is
Sir,
yes.
can I note down the sedimentation definition?
Okay, sedimentation definition. Okay, do one thing. Remind me at the end of the class. I will share the screenshots. Okay, no?
Yes, sir.
Okay. I will share the screenshot of sedimentation, decantation, and filtration also. Okay. So we learned about filtration also. So it was the process of passing the mixture through a filter paper to remove solid particles from the fluid components of the mixture. From the fluid basically refers to liquid. So here you are separating the solid component of a mixture from a liquid component of the mixture. For instance, if you were
Sir,
to pass
sir, may like some soil or some dirt from water.
exactly right now. So we see that generally soil, dirt, or mud can be separated from the water via sedimentation and decantation also, right? Okay, but
Yes.
it can be done with the help of a filter paper also, right now. This can be done with the help of filter paper also, where we will make the impure water pass through a filter paper. A filter paper has got very tiny holes in it. It is very tiny. So thereby we will pass the impure water through it and all the impurities will be left in the filter paper. And at the end you will be having a clear liquid. The clear liquid that you get out from this will be called as filtrate. Filtrate. Okay, no? So after filtration, the clear liquid that you get, that is called as filtrate. So these are the things which we learned. Okay. Now today we would be learning about another methods of separation. We'd be learning about evaporation, condensation. Okay, no? And distillation also. Okay. And how the salts are obtained. Okay, now how salts are obtained. We'd be learning about that too. Okay.
Yes.
So these are the things we should be learning today. First of all, let us start from condensation, from evaporation, I would say. First of all, uh, first now read the first paragraph. Hana, you read the first paragraph.
Condensation. The process of conversion of water vapor into its liquid form due to contact with cooler surface is called condensation. Example, formation of water droplets on metallic lid when boiling water.
Good. Right now. So that is called as condensation, as you would have already learned previously also. Ira, you read the given paragraph.
Sir,
Next paragraph.
evaporation.
Yeah.
Evaporation. The process of conversion of water into its vapor is called evaporation. The process of evaporation takes place continuously wherever water is present.
Wherever water is present. So condensation and evaporation, it's a phenomenon that we are experiencing every day. We experience it everywhere right now. So first
Yes.
of all, we are going to learn about how evaporation and condensation is used in the separation of substances right now.
Yes, sir.
So there's a concept called as distillation. Distillation is a technique that is used to separate two or more than two liquids according to their boiling points. The concepts which you have learned right now about condensation and evaporation, these two concepts would be used in separation of two or more than two mixtures of liquids. A
Yes.
mixture of two or more than two liquids. How boiling and condensation will be used there. Okay, let me add few important points about condensation and evaporation. Okay, so we know that there's a process called as evaporation, right? In evaporation, basically what will happen, a given substance from a liquid state will convert into the gaseous state. It will convert from the liquid to the gaseous state. That is
Yes.
called as evaporation. And evaporation can, like water can evaporate at any temperature. Getting it?
Sir,
Like,
sir, also when there are like small puddles of water on the road, then sometimes after some time, like they will turn into water vapor and disappear
exactly, right?
with the
But
heat of the sun.
exactly. So water can evaporate at any temperature. So normally what we have learned that you guys would have learned about boiling temperature of water, that is how much? 100 degrees Celsius is the boiling point of water, where the
Yes.
water starts to boil. So at the boiling temperature, that is 100 degrees Celsius, at that temperature also evaporation is taking place. At that temperature also water is converting into the water vapor. That is the gas. At that temperature also it is happening. But a general question, as a very good example Hana gave, that many times in the streets or on the roads we get to
Sir,
see that.
Ira gives that example.
I gave this example, no? Oh, okay, sorry. No worries. So water puddles would also be evaporating, right? So why does it happen? Did someone went there to boil it, to heat it? Of course no. So evaporation of water can happen at any temperature. That has to be just above the freezing point. That has to be just above 0 degrees Celsius. Getting it now?
Yes, sir.
So
Yes, sir.
for water to convert from the liquid state to the gaseous state, the temperature should be above 0 degrees Celsius right now. So even if it is 1 degree Celsius, 2 degrees Celsius, up to 100 or even more than 100, it will be converting into the gaseous state. That is what I was trying to say. So for evaporation, no fixed temperature is required. It can happen at any temperature, but should be above the freezing point. Okay, now
Yes, sir.
hope you guys have understood this so far. Okay. Also, the thing is that the rate of evaporation will be maximum at 100 degrees Celsius. That is the important point here. Okay. Like if you have, for example, if I were to have, I have a cup of water, say, and if I were to leave this cup open in my room for a week, after 1 week, I will observe that the level of water would have went down. It will go down in this cup. because
Because the
of
water will turn into water vapor and it will go.
exactly. But there, I didn't raise its temperature to 100 degrees Celsius right now. So
Yes.
it basically
Yes.
absorbed the heat from the surrounding and then converted into the vaporous state. That is the thing. Furthermore,
Sir,
what happens?
Sir, for water to turn into water vapor, it has a fixed temperature.
For water to turn into water vapor, no, it does not have a fixed temperature. It will start to convert into the water vapor above the freezing point.
Assalamu alaikum, sir.
Yeah, walaikum assalam, Halima. Okay, na? See, water can evaporate at any temperature above the freezing point. Water can evaporate at any temperature above the freezing point. Keep that in mind. It is not necessary that the temperature has to be like 100 degrees Celsius or 200 degrees Celsius. Getting it, guys, what I'm trying to say.
Yes.
Yes.
Okay. So that is the thing. But the thing is that at 100 degrees Celsius, the rate of evaporation will be very high. That is the thing. Got this, both of you?
Yes, sir.
Yes, sir.
Okay. Now, in the case of evaporation, heat was being supplied. Heat was being used by evaporation. Right, Halima, Hana, and Ira?
Yes,
Yes.
sir.
Right? Okay, water requires heat. But in the case of condensation, opposite situation is required. There, what happens? Water is converting from the water vapor
To
or
water droplets.
exactly to water droplets. So, water vapor meaning that it is the gaseous state of the water, right? And water droplet meaning that it is the liquid state of the water. So, there it is converting from the gas to the liquid. Now, you'd have noticed down that there the temperature is not being required. The water does not require heat, but rather than requiring heat, the heat has to be taken away from it. I mean to say that the temperature has to be reduced.
Yes, sir.
That's why what we get to see that as the water vapor would be rising. Just 1 minute. Yeah, I was saying that as we know about the water cycle that is happening in the nature, how rainfall occurs. Huh? First of all, we see that from the vegetation, from the water bodies, vapor would be rising higher up in the sky. Water vapor rises high in the sky. Getting it now? So
Yes,
these are
sir.
the water vapor. Say this is a lake. From this water vapor is rising high in the sky, and there it leads to formation of cloud. Right there, it leads to formation of cloud, and this is the water vapor. So how this water vapor forms cloud? The water vapor will convert into cloud when condensation will take place. When these water vapor will convert into water droplets.
Sir,
Then yes,
you're talking about distillation.
yeah, we are going to learn about the concept of distillation, but before that, we are learning the basics of condensation and evaporation.
Okay.
So in the nature, we get to see that first of all, evaporation is taking place from the lake, from the vegetation, and as the water vapor goes higher up in the sky, there the temperature is lower down, and hence it converts into clouds. So there, condensation is taking place now. Give me a minute. So I was saying that here the condensation will be taking place. So as we also know this thing that as you go higher up in the sky, the temperature drops. As you go higher up in the sky, the temperature reduces. So it's a thing of observation. There we get to see that at higher above in the sky, the water vapor would be converting into the water droplets. And how does that happen? Because the temperature drops. In the higher up in the sky, the temperature drops. So there condensation is happening. So condensation is the process of conversion of water vapor from its water vapor into its liquid state due to coming in contact with a cooler surface, or if the temperature in the surrounding drops, it reduces. Or as you can see in this image over here, that gives a very good description of both evaporation and condensation happening at the same place. Here we get to see that the water vapor is rising as this water is being boiled here. Getting it, guys? The water vapor is rising over. Look over this one over here. As the water in this kettle is being boiled, so the water vapor is coming from this side. And as this water vapor comes in contact with this plate over which you have placed the ice cube, so the plate surface is cool now. It's a cool surface, right? And here hot water vapor is rising. So as the hot water vapor comes in contact with a cool surface, it then converts into water droplets. So thereby you have also observed this, that droplets of water vapor would develop on this plate, and then it will start to fall on the other side and will accumulate in this. It will be stored in this glass beaker. You guys understood this basic concept or not? Yes.
Yes, sir.
Okay, now. So that is the concept of
Yeah.
evaporation and condensation. Okay. Then we are going to learn this how evaporation and condensation is used in the process of distillation. So let us learn about distillation. So first of all, Halima, read the given paragraph.
Distillation. Distillation is a technique to separate two or more than two liquids according to their boiling
According to the boiling
point.
point.
Distillation is commonly used to separate ethanol, the alcohol, in the alcoholic.
Okay, we are going to learn about the examples later on. Okay, now first of all, learn about distillation. See, distillation will be basically done for separating those two liquids, those liquids of a mixture which have different boiling points, which have got different boiling point. So, say for example, in this flask we have different kind of mixtures. Say for example, in this we have mixture A and B, mixture B. We have liquid A and liquid B. So liquid A in this mixture has got, let's say, the boiling point of, let us say, 120 degrees Celsius. Okay. It has got 120 degrees Celsius a boiling point. And liquid B has got a boiling point of 100 degrees Celsius. That is basically water, for example. Okay. Now both of them are mixed together and we want to separate the water from this mixture. How are we going to do this? So now look over the setup. So we have taken a glass flask, and in this glass structure, we have first of all put the mixture of the two liquids A and B, and we start to heat the mixture. So first of all, we will increase the temperature to 100 degrees Celsius. Okay, now first of all, we will increase the temperature to 100 degrees Celsius. Also, we can measure the temperature inside and measure the temperature of the mixture using a laboratory thermometer. This is a laboratory thermometer, let's say, which we have put inside this. So using the laboratory thermometer, we can check the temperature of the liquid. So as soon as the temperature of the liquid would have reached 100 degrees Celsius, so thereby we will, basically the thing over here is that we will try to maintain the temperature of the mixture at 100 degrees Celsius initially. Okay, now? So at 100 degrees Celsius, what will happen? Liquid B, it will, almost all of the liquid B would have converted into the vapor state. Also, we know that liquid B, it is basically water. For example, here we have taken its water. Getting it, guys, so far now? So we have maintained the temperature of the mixture at 100 degrees Celsius. So thereby, liquid B will convert into the vapor state. It will start to convert into the vapor. And it will start to come into the vapor, and then it will go into this pipe. The vapor of liquid B, it goes into this pipe. So far, is it clear to everyone? Halima? Okay, Halima is not here. Halima, Ira, and Hana. What we have done so far, is it clear to everyone?
Yes, sir.
Hana, you getting it?
Sir, there was
Yes, sir.
connection. So what was the thing?
I was saying that in this glass, we have taken a mixture of two liquid A and B, and the boiling point of them are different, namely 100 degrees Celsius and 120 degrees Celsius. And we want to separate these liquids from each other. Okay. So first, what we have done here, would maintain the temperature of the mixture at 100 degrees Celsius. So at 100 degrees Celsius, all the this liquid B will convert into the vapor. It will convert into gas that is in its vapor. So then
Yes.
the vapors of liquid B, it will start to rise. It will start to rise, and then it will go into this pipe, the one that is over here. And now you can see over here that this structure, in this we are putting water. We are putting cold water in this. So this glass structure that you are seeing over here now, in this we are pouring cold water so that the tube remains cold. Okay, now the water, this pipe over here, it is hollow. We are not putting water into this pipe. Basically, this is structure that you see over here, which I'm going to mark this structure. In this, we are pouring cold water so that we keep it cool. Also, we know that when vapors comes in contact with a cold surface, it turns into droplets. It converts into the liquid state. Isn't that the case? Ira, Hana, and Halima.
Yes,
Yes.
sir.
In the case of condensation, we have learned that when hot
Sir?
vapors will come in contact with cold surface, it will start to convert into its liquid state. So same thing is happening here now.
Yes.
Just let me just complete this one. Then I would be taking your doubts. Okay. So the vapors of liquid B will convert into the droplets, and it will be collected into this
Yes.
glass flask. Okay, now also we know 100 degrees Celsius, it's the boiling point of water. So actually liquid B was water, so which we have collected in the glass flask. And what would be left in this flask? In this glass,
Liquid A.
liquid A will be left.
Sir,
So is it clear to everyone? Yeah.
Yes,
I
sir.
have a doubt.
Yes, Salima.
Sir, you are saying that the boiling point will have to be only in 100 degrees, right?
Yeah, for water, it is we know it's 100 degrees Celsius.
But sir, why are we supposed to keep only at 100 degrees?
Okay, why are we supposed to keep at 100 degrees Celsius? Okay, we are supposed to keep the temperature of the solution of the mixture at 100 degrees Celsius, so that all the particles of liquid B converts into the gaseous state, so that
Yeah.
none of it is left. Okay, now
Sir, what will happen if we keep it at 130 degrees?
130 degrees Celsius.
Yeah.
If we were to do that now, then what will happen? Both the liquid B and A, both liquid B and A, both of them will go into this structure, and both of them will be cooled down, and both of them will fall into this glass flask. Getting it done? Because there you have provided 120 degrees Celsius also now, like I mean to say, when you have raised the temperature above 120 degrees Celsius, that is 130 degrees Celsius. Thereby, both the liquids will completely turn into the vapor state, and both of them will go into this structure. It will be cooled down, condensation will take place, and it will fall into this glass flask. You guys understanding what I'm trying to say?
Sir? Yes,
Yes.
sir.
Sir, what will happen
Sir, if liquid B was a different, was like 113, liquid A was 120, we still have to keep the temperature as 100.
Halima, Ira, will you please repeat your question once again?
Sir, if liquid A was 113, liquid B was 120, we still have to keep the temperature as 100.
No, there we will keep the temperature of there we will first of all maintain the temperature of that liquid which has a lower temperature. Okay, na?
Okay.
Mhm.
Okay.
Sir,
Yeah, Halima.
what will happen if we keep it below 100?
Below 100, thereby distillation will not work in a proper manner. Okay, na? The particles of liquid B will not properly convert into the vapor state. So for the efficiency, to make it very efficient, we must keep the temperature to 100 degrees Celsius. Getting it now? So
Yes.
that is the technique of distillation. It is based on the property that different liquids of a mixture have different boiling points. Like liquid B had 100 degrees Celsius at which it will boil. Liquid A had 120 degrees Celsius at which it will boil. So that is the whole concept of it. Okay, now difference in boiling point is
Yes,
important.
sir.
Getting it now? So hope you guys have understood this one. If anyone has any questions in it, please let me know.
Sir, we have done this distillation thing in the physics lab.
Oh, that's good. You have done this. Very good.
Yes, sir. But
Okay.
sir, we had done a mistake for this. Like we forgot to put it in the 100 degree, and by mistakenly we have
Mhm.
put it below 100 degree.
Okay, okay. There you'd have might have had a different liquid. Okay, now. So hope that was clear to everyone. Okay. Next,
Yes.
by the way, this is a separation technique that is used, and where it is used to obtain important products from. For
Sir,
example, I'm just giving you one example. Yeah, Halima.
sir, this is used like for two liquids.
Yeah, two liquids. I'm telling you about the examples. Like distillation is um, the process of distillation is used to obtain distilled water. That's why that water is also is being called as distilled water. Getting it now? So obtaining distilled water is very simple. Simply basically boil the water and then condense the water. Collect the steam of the boiling water in a container. Thereby, you would be having a liquid called as distilled water. Right now, like the one that you see in this image over here, this water will be called as distilled water. Getting it now? So this one is also kind of an example where we get to see that distillation would be happening, but here we have just one liquid. Okay. Then furthermore, distillation will be used in refining of petroleum. Distillation is used in the refining of petroleum also. So what happens now? The petroleum that is taken out from the earth, it is in crude state. It is not in a usable state. Huh? So there, what will be happening now? We would basically take the petrol and we will put it into a furnace. So petroleum would be first of all put into a petroleum refinery. Okay, it would be put into a petroleum refinery like this. Let me show you this slide over here.
So these are done in factories.
Yeah, of course, these are done in the factories. Look at this one over here. Okay, now see what I'm trying to say over say you guys here that petroleum that is dug out from the earth, it is in the raw state, and at that time it cannot be used. Okay, because it's a mixture of different substances. So first of all, yes,
Distillation can also be used for alcohol.
yeah, there also it is used. Getting it? We'll be learning about that too. Let us
But this
understand about this.
is used for oil purifying.
Yeah, exactly. For purifying the petrol. Okay, now to obtain the different components from the petroleum. So petroleum, that is the crude oil which we obtain from the earth, actually it is in the raw state and thereby it is not fit for the use. So first of all, it would be boiled, it would be heated in a furnace. The crude oil is heated in a furnace. So first of all, In the furnace, the temperature would be maintained at 20 degrees Celsius. Okay. So at 20 degrees Celsius, the liquefied petroleum gas will be coming out of it. Then you will cool it down. What happens at 20 degrees Celsius? LPG gas comes out from this chamber. Then it will be coming in the form of gas now. So then later on we will cool it. So you have first of all boiled it, raised the temperature to 20 degrees Celsius, then cooled it. Right. So condensation has happened here. Then the boiling point of petrol is 150 degrees Celsius. For kerosene, it is 200. For diesel, it is 300. And for fuel oil, it is 370 degrees Celsius. So petroleum, it's a mixture of different things, and all of them have different boiling points. Right now, same thing moments ago, which we were learning that in the case of distillation, two or more than two liquids of different boiling points are separated using distillation. Here also, crude oil, it's a mixture of different liquids, and different liquids have different boiling points. So distillation will be done for that also. You guys getting the basics what I'm trying to tell you?
Yes, sir.
Yes, sir.
Good. So there also petroleum, there also distillation is used.
Sir, so from this crude oil, we just need to get petrol.
Not just petrol, we need to get kerosene also. We need to get is my screen is stuck?
No, sir.
Yeah.
Sir, it's not moving, but.
Yeah, that I noticed that it's
Sir,
not
it
moving.
is stuck for me.
Yeah, now is it visible?
Yes, sir, it's visible.
Yeah, sorry
Sir,
about the
it is
interruption.
still stuck for the start.
Maybe you had a connection issue, I think, Halima, now. So what I was saying that here we can see that petroleum is a mixture of different liquids, and all of them would be
And now I
separated
get
by the good. Why the process of distillation, all of them would be separated. So first of all, we would be heating it to 20 degrees Celsius. Then we'll raise the temperature to 150 degrees Celsius. So at this temperature, the vapors of petrol would be boiling. It would be boiling, and the petrol would be boiling, and it will convert into the vapor state, and will be taken out by this pipe. Thereby, it will be cooled down. So just to give you a brief idea about that concept of the usage of distillation, I showed you that slide. Let us continue from where we left. Furthermore, distillation would be commonly used to separate the ethanol, that is alcohol in the alcoholic drinks, from water. To separate the alcohol from water, also distillation is done. Getting it now? So the first example you will write down that separation of different products from crude oil. That is where it will be used. Furthermore, I told you that distillation will be commonly used to separate alcohol from water.
Sir?
Yes.
Sir, we need to write like distillation is commonly used to separate ethanol. Like,
No, I will be telling you what you have to write. Okay, no.
Okay.
First of all, write this definition. Distillation. Give the topic distillation.
Sir, I already wrote that.
Very
Sir, I
good.
already wrote everything.
Okay, for those of you who haven't noted it down, just write down this point. Distillation is a technique to separate two or more than two liquids according to their boiling point. Then give the first example. Next example, you would be giving down that it would be used for separation of water from alcohol also. So just write down distillation is commonly used to separate. Don't write ethanol, just write the alcohol from water. No need to write the alcoholic drinks. So here, let us understand how it happens. First of all, let me clean this. See, alcohol and water, they have different boiling points. Water boils at 100 degrees Celsius while alcohol boils at 78 degrees Celsius. It boils at just 78 degrees Celsius. So both of them have different boiling points now. right?
Yes, sir. So
So
when we're doing distillation, we need to put it at the temperature of alcohol.
exactly, right now. So now in the place of liquid A and liquid B, think of them as alcohol and water. So liquid A, it is, let us say, alcohol, and liquid B, think of this as water, right? Water has 100 degrees Celsius, alcohol has 78 degrees Celsius boiling temperature. So then in this setup, we would first of all maintain the temperature at 78 degrees Celsius. Thereby, all the alcohol will convert into the vapor state. It will go into this structure where it will be cooled down and it will convert into the droplets, right? Also, here condensation is taking place now, right? So drops of alcohol will fall into this glass flask. This is called as glass flask, in which the drops of alcohol would fall, and thereby you will be having alcohol in this. In this manner, we'd be able to separate alcohol from water. Water will be left in this glass, and alcohol would be separated in this glass flask. The example of alcohol and water, was that clear to everyone?
Yes, sir.
Hana, you getting these concepts now, and Halima?
Yes, sir.
Good. So these are the two uses of distillation. Also, in a bracket, you guys will be writing down this also, that difference in boiling point is the property used in distillation.
Sir, already wrote that.
Already wrote that. Very good. After this, you'd be learning about.
Sir,
Yes.
some water bottles, they'll also be written like distilled and still water.
Yeah, some water, you see that it would be labeled as distilled water right now. So,
Sir, just give me 1 minute.
Yes.
okay. Yeah. So I was saying that distilled water will also be there. So basically that distilled water will be obtained in why the process of distillation. Okay, no? Distilled water will be obtained by the process of distillation. Yes.
Sir, is it okay if I leave now?
Okay, okay, Hannah. Yeah. Okay, then we'll meet in next class then, Hannah. Bye. Yeah, so Ira and Halima, you guys, what we were talking about, distilled water. So distilled water is also obtained by the process of distillation. Okay, now we should first of all involve the heating. First of all, it will involve boiling of the water and then cooling it back to get the water. So that is how distillation will be done. Okay, now also distilled water is considered to be one like the purest form of water, right? It is called as purest form of the water because it is free from any impurities, and hence distilled water be considered as the purest form of water.
Okay, sir.
All of you done writing this?
Yes, sir, I finished writing.
Good. Now let us understand how evaporation will be used to obtain the salt from the seawater. Do you guys know about this? How water is evaporated to obtain salt from
Sir,
it?
I'm not sure, but maybe they take the water from the oceans and then they let the water get evaporated and then the sea salt is just left.
Very good. So here you can see over here that the salt water has been trapped into the shallow ponds. These are the shallow ponds in which the salt water has been trapped right now. Okay. So the salt water, we know that salt is already present in it, right? So what if we were able to separate the salt from the salt water? That salt will be used for the commercial, for the different purposes it can be used. So the salt will be obtained from the salt water via a natural process called as solar evaporation. What is this called as? Solar evaporation, right? So here the source of heat is basically sun. The source of heat is sun. That's why it is called as solar evaporation. You are not manually or you're not heating it via some machines. You are not heating it. Okay, now you are not burning anything to heat this water. So the people would be simply constructing the shallow ponds like this, in which the water would be accumulated and it would be left to be dried. Okay, now So evaporation will be taking place, right? So as the salt water will be trapped into these shallow ponds, they are being continuously exposed to the sunlight. And due to the sunlight, the water will be evaporating and then it will leave behind the salt. As you can see in this image, the salts have been collected like this over here. Okay, now. Furthermore, these salts are also right now it is not pure. So furthermore, it has to be made pure, right now. So via the use of machines, it would be made pure. Okay. Also, we know that here in this thing we see that salt has much higher boiling point than the water. That is why it is left behind. That is why it did not converted into the vapor. Like salt has a very higher boiling point as compared to the water. That is why the water evaporated in the sunlight, but the salt did not evaporated. Getting it this now?
Yes, sir.
Okay. So hope that is clear to everyone. Halima, you understood this now? Okay.
Yes, sir.
Ira, read the given paragraph.
Shallow pits called evaporation ponds are constructed and salt water is allowed to stand in these. After some time, the water gets evaporated, leaving behind the salts. Common salt is separated from this mixture upon further purification.
Right, so common salt will be separated from, like this is a mixture, this there will be several impurities in it also, right? Because salt water, the salt water, the sea water not just contains salt, but apart from salt it contains other impurities in it also that needs to be removed, right? It could be dead remains of the fishes, it could be fish bones or other impurities or
There
stones
could also
also.
be maybe some of the sand from underneath.
Of course sand will also be in it. So that is not fit for consumption, so thereby it needs to be further purified. Okay, no? So that is the thing, the salt water obtained from evaporation will be further purified and then it will be used, right? Okay, so further furthermore we also we get to see this thing that um that it's a normal thing, like if you were to add 2 or 3 tablespoons of salt or sugar in a glass of water, after that no more salt or sugar will be dissolved in it. There will come a time that it will not dissolve any more sugar or salt
It
in
will
it.
become insoluble.
It becomes insoluble then, right? Now, so what happened? See, the question is, can water dissolve it all? Can water dissolve any amount of given substance? The answer is of course no, right? Now, the answer to this is no. There is some limit to it. So before we discuss this thing further, there are few important terminologies which we need to understand. Halima, you there in the class? You're not saying anything.
Yes, sir.
Okay. So see, there are some terms which you guys need to understand. Say in a glass of water, you were to add a tablespoon of sugar. And this is water, and this is the solid substance which you are going to add into this. Okay. Now you are dissolving the sugar, or you're dissolving the sugar into the water, and it is in a smaller quantity. So this sugar or any other thing, let it be like a salt or some other thing which you are going to dissolve in the water, which is present in higher quantity. Okay. So this substance that you are dissolving into it, that is called as solute. That is called as solute. And the thing in which it is being dissolved, that is called as solvent. That is called as solvent. Also, it is a mixture. So in a mixture, a substance that is being dissolved into another substance is called as solvent. Right now, I mean to say that the substance that is being dissolved into another substance, it is the solute. And the substance in which it is being dissolved, that is called as solvent. Just like, for example, if you were to have, let us say, oil, okay, And in oil, you have, let us say, put something. You have put some tiny grains. Let us say these are tiny grains. See, for example, we have taken grains of rice. So here in this mixture, the oil is the solvent and rice grains are the solute. Oil is the solvent while the rice grains are solute. Getting it, Halima and Ira?
Yes, sir.
Okay, now.
Yes,
So the substance which is being dissolved, that is called a solute. The substance like the sugar that is being dissolved, or the rice grains that is being dissolved, that is being called a solute. And the substance into which they are being dissolved, that is called a solvent. And always solvent will be present in a greater amount, in greater quantity. Getting it, guys? So these terms are
Yes,
clear
sir.
to both of you or not?
Yes, sir.
Good. Okay. Also, we know that air is a mixture now. Air is also a mixture. So the dirt particles that you see floating in a polluted air, that can be taken as solute, which is present in a smaller quantity. And air into which the dirt particles are suspended, that air will be called as solvent. Okay, I'm giving you guys one example. You have to tell me which one is solute, which one is solvent. Okay. uh, Ira, you tell me, out of sand and water in this mixture, out of sand and water, which one is solvent?
Sir, solvent,
Solvent. Yeah,
the water.
water. Okay. What about you, Halima? Which one is solute?
Sir, sand.
Sand will be solute. Which one is present in greater quantity?
What, sir?
Which one
The
is
water.
present in more quantity? Of course, water.
Water.
Okay.
Water.
Also we'll find that the solvent will be present in greater quantity. Keep that in mind. And solid is present in a smaller quantity. Okay, then. Now let us understand the important thing. Okay. Say here, uh, talking about saturated solution, let us learn about what a saturated solution is. For example, you have made a solution. Also, one more thing, guys. So there's one more thing you need to understand. We use this term many often, solution. Solution is basically a mixture of solute and solvent is called a solution. Okay, no? Like when you mix sand and water, it becomes a solution. Okay. When you mix sugar or salt in water, that becomes a solution. The solution will be made up of solute and solvent. Keep that in mind.
Sir, so solution is made with two like different
Hmm.
like it's
So
like a solution is like the mixture, right?
it's a mixture and it will be made up of two different things. Basically, one will be solute, another one will be solvent. We can have examples. So we have so many different solutions. For example, lemon water, that is also a solution, isn't it?
Yes, sir. Sir, it can be only done with two things or like
No,
two or more.
more than that, too. More than two. For example, here we have taken some sugar, we have taken lemon, and we have taken water. We can take some other things also. So that is a solution. And a solution can have more than two solutes, right? For example, here you have added sugar. What if you were to add salt in it also? Then how many solutes you have added into this?
Sir, into what? Into
How
the
many into the water?
sir two.
Two, right now. You're getting it now, Halima also and Ira.
Yes,
Okay.
sir. Yes, sir.
Halima, you read the given paragraph up to here.
Okay. saturated solution. A
Hmm.
saturated solution is a chemical solution containing the maximum concentration of a solute dissolved in the solid.
Okay. So say for example, we had a glass of water, and in this we can add only 3 tablespoons. We can only add 3 tablespoons of, let us say, salt in it. After that, you will not be able to add any more in it. If you were to add any more salt in it, then it will simply settle at the bottom. So then that solution is being called a saturated solution, in which no more solute can be added. The concentration of solute is maximum in it. That is called a saturated solution. Either read the given example.
For example, a saturated solution of salt in water is one in which no more salt can be dissolved. This added salt will just sediment down to the bottom of the vessel.
Good. Okay, you guys tell me that the moment when we had added only like 1 tablespoon of salt in the water, in that water. So at that time, was it a saturated solution or unsaturated solution?
So saturated.
No, no, only when you have added just 1 tablespoon of salt, while
Oh,
2 more tablespoons of salt can
unsaturated.
be added. Uh, so at that time, it's an
Unsaturated.
unsaturated solution. Very good. In which some solute can be added. A unsaturated solution is the one in which more solute can be added. Okay, now. Okay. Now, furthermore, what happens now? In some cases, the saturation or the solubility of the given solute, like meaning that in some case, not in some case, generally it is seen that if I were to increase the temperature, if I were to heat this water, getting it, so thereby I can add 1 more tablespoon in it, plus 1 tablespoon of salt can be added into this. So by heating, the solubility of the given solution can be increased. Getting it, you guys, what I'm trying to say? By heating, we can
Yes.
increase the solubility of the solid in it. That is the thing. Okay. So here are the differences between the two. First difference, Halima, you read the first difference between the two.
Sir,
Halima?
saturated solution contains the maximum amount of dissolved solute. Unsaturated solution cannot contain less than maximum amount of dissolved solute.
Got this now? Clear to both of you?
Yes, sir.
Ira, read the next paragraph. Next difference.
Saturated solution. More solute cannot be added without raising the temperature. Unsaturated solution. More solute can be added without raising the temperature.
Right? Okay. So in the case of this saturated solution of a this saturated solution, here no more solute, no more tablespoon salt can, no more salt can be added into it without raising the temperature. Then that's a saturated solution. And here in the case of the unsaturated solution, we get to see that more amount of salt can be added into it without raising the temperature.
So
Getting it
it
now?
can be added more until it becomes unsaturated.
Exactly. Until it becomes saturated, you mean to say. Right now, you can add more salt in it until it becomes saturated. Okay. Further, what if you want to add 1 more tablespoon salt into this? Then you will have to
Add
increase the temperature.
increase the temperature.
Getting it now? So that is the important thing. Okay. So here we have learned about so many different techniques of separation. Right now we are going to learn about the churning. So you all would have seen that churning, like the woman would be churning, and churning is done
But
to
to make
obtain
butter.
butter. Exactly. Right now. So here they are kind of shaking up the milk to make butter. Scientifically, this process is called as centrifugation. Okay, now which we will be learning about in a minute. All of you have a look at this, right? So churning, it's the kind of shaking up the cream or the whole milk to obtain butter out of it. So like this one setup that you see over here, in this, first of all, milk will be put into this, and this wood would be rotated. or like the one that you can see in this first image over here. So the woman is pulling some thread, pulling some strings, and while pulling the strings, she is making this wooden structure rotate. And inside this, the wooden structure would be kind of like this. It would be kind of like this. So here it would be mixing the milk. It would be mixing the milk. So this mixing or shaking of the milk is the churning process. So let us understand how basically churning is happening here, right? So when we are churning up the milk now, thereby what happens? The denser particles of the milk, the particle that are heavier, it accumulates at the surface of the pot. It's accumulates at the surface of the pot. So basically, it is working uh, on the principle of centrifugation. So what happens in the method of centrifugation? Uh, so in the case of centrifugation, what happens in a, like for example, in milk, you'd have seen that many times a yellow particle would be floating at the top of the milk. Have you guys noticed that? Like,
Yes, yes, sir.
you'd have noticed that, no? So those yellow particles are kind of suspended into it now, right? So centrifugation process would be used in order to separate the in order to separate the suspended particles present in a liquid by spinning the mixture at very high speed. So here the mixture is kind of being spinned at very high speed. So thereby I will show an animation of it in the next class that will give you a very better clarity of the whole process of churning or centrifugation. So where the mixture would be spin at a very high speed, and due to that spinning, the heavier particles suspended in the mixture, it will settle at the surface of the container or the surface of this pot, for example, here. Getting this?
Yes, sir.
So this will be from here we'll be continuing in the next class. If you guys have any questions, please let me know.
Okay, sir.
Okay. Okay, then Ira and Halima will be meeting in next class then.
Okay, thank you, sir. Can I leave?
Okay.